Example 4 re-looks at some of the stuff we did in example 1 and 2, where you have vertical stretches, horizontal stretches, but we're also going to look in part C at what happens when you translate something up or down. So A and B are review. Okay? If we were going to graph y equals 3 sine x, that 3 outside this is a vertical stretch. And anytime you have a value outside of a sine or cosine graph, it's going to affect its amplitude. So when I draw this, instead of having a maximum value at 1 and a minimum value at -1, I now have a maximum value at 3 and a minimum value at -3. For graphing a sine graph, we're always going to label one period, and since the period of sine is 2 pi, we mark 2 pi and divide it into 4 equal sections. So half of 2 pi is pi, half of pi is pi over 2, and this will be 3 pi over 2. A sine graph always starts on your center line going up, so this graph will start on our center line, then go to our maximum, back to our center line, down to our minimum, and back to our center line. So again here, I'm drawing it with arrowheads, continued. They've labeled the domain from 0 to 2 pi, so if you had started it at 0 and ended it at 2 pi, that would be exactly what they're wanting. In part B, this is also a review. This one has the 3 inside. And so that's going to affect your period, and we introduce this formula, but this formula should make sense to you. This is why it's not on your formula sheet, because if the period of sine is normally 2 pi, and when we have a 3 in here, that would be a horizontal compression. You would multiply all your x values by 1/3. So what happens is your period that was 2 pi, when it gets multiplied by 1/3, it gets compressed. Can you see that your period would now be 2 pi over 3? And if we use the formula, well, the formula says put your b value on the bottom, and our b value is a 3. That b value on the bottom is the same as multiplying by 1 over b, which is the same idea as what we've done all along with our horizontal compressions. So what does this mean for graphing this? This time there's no vertical stretch or compression, so our maximum is 1 and our minimum is -1. Our period, we always mark one period. Instead of marking 2 pi here, now we're going to mark 2 pi over 3. And we're going to still divide this into 4 equal sections. So half of 2 pi over 3 is pi over 3. Half of pi over 3 is pi over 6. And once you get this first one, you can count 1 pi over 6, 2 pi over 6. This will be 3 pi over 6. You could reduce that and write pi over 2 if you wanted to, or you can leave it as 3 pi over 6. And now where does a sine graph start? In the middle going up. So now there's our maximum, back to our center line, down to our minimum, back to our center line. And again, this one said stop at these ones. I'm just going to put arrowheads to show that that would keep on going if you needed to graph more. So those first two questions were a review of what we did before. It's in part C that we get introduced to the last transformation. What happens when you have a +3 after the function? Well, from our translations unit, or transformations unit, we would know that this is a vertical translation. You would go 3 units up. What does that affect in a sine and cosine graph, and how are we going to use that as a shortcut? Well, When I move it 3 units up, what it's going to do is it's going to move your center line. Another name for your center line is your sinusoidal axis. And we're going to label that with a dotted line, dotted red line, just like we label our asymptotes. It's not part of the graph, but it helps us graph. It's our center line. And so once you have that center line, the amplitude of this function is still 1. So once you have your center line, if my amplitude is 1, and remember our definition of an amplitude is the distance from the center line to a maximum or from the center line to a minimum, I now know that my maximum is going to be at 4 and my minimum is going to be at 2. Since our whole graph has been moved up that way, amplitude is still 1, but now our center line's at 3, our maximum will be at 4, and our minimum will be at 2. We still go along our x-axis and mark 1 period. Our period in this case is 2 pi. We still divide it into 4 equal sections. And now for graphing this, this is why all along I've been saying our sine graph starts in the middle going up. So here's our middle. Going up, that means at pi over 2 it will hit our maximum. Then at pi it'll be back to your center line. At 3 pi over 2 it'll go to your minimum, and at 2 pi, and that is the graph from 0 to 2 pi. If it said to graph more, you could add arrowheads to say that this keeps on going and shifting forever. What we do in the next section is we put all of these things together. So far we've only had questions which has one transformation in it, either affecting your amplitude with a vertical stretch or compression, affecting your period with a horizontal stretch or compression, shifting it left and right, and now shifting it up and down. And with shifting it up and down, the key thing that we're going to see here is our center line moves. And when our center line moves, we can use our amplitude, our A value, to figure out our new maximum and new minimum. And this is going to help us develop a shortcut for graphing sine and cosine graphs. Okay, the ones I'd like you to do for practice right now are 6 and 7.